Hi guys, tonight we're going to start part 2 of Unit 2, and we're going to take a look at direct variation. We ended part 1 of Unit 2 looking at average rate of change and rate of change, and with this unit, part 2 of Unit 2, we're going to continue with that rate of change theme, and tonight we're going to look at direct variation. So direct variation is a function, so here's that function word again. It's a function in the form of y equals kx. And k is called the constant of variation. And basically that k just means things vary directly. And it's always the coefficient of x. The variables y and x are said to vary directly. And that just means that they're proportional, they have the same ratio. So if an equation has direct variation, how can we tell? Well, it has direct variation when the y-intercept is 0. And that just means that it has to pass through the origin. If it doesn't pass through the origin, it doesn't have direct variation. So let's look at example 1. We're looking for the constant of variation. We're looking for k, and it's just the coefficient of x. So k equals 3. That's our constant of variation. In example 2, we're also looking for the constant of variation. When the equation is in the form y equals, we look for the coefficient of x, and really there's a -1 there. So the constant of variation is -1. So in these examples below, in example 1, 2, and 3, we have to tell whether each equation has direct variation, and if it is, find the constant of variation. And your equation to find the constant of variation has to be in y equals form. And so number 1 is, if we graphed it, would this pass through the origin on the coordinate grid? And the answer is yes. So the constant of variation is the coefficient of x. It's k equals 2. So how can you tell just by looking at the equation? Well, I have a y and I have an x, and I don't have anything else hanging on. X has a coefficient, y doesn't. So in example 2, I don't have this in y equals form, so I need to get it there. And when I do that, I start by subtracting 2x from each side, and I get 5y equals 1 minus 2x. Divide by 5, and I get y equals 1/5 minus 2/5 x. So does this have direct variation? And the answer is no. And how can I tell? Because this constant over here, this 1/5, is hanging on. If it just said y equals -2/5 x, yeah, I'd be good. But because that 1/5 is there, that means it does not pass through the origin. Number 3, we also have to get this into y equals form. If you want to rewrite it, if that makes you happier, make that -12x. Divide by 6, and we get y equals -2x. So if we look at this, y does not have a coefficient, so we're good. X has a coefficient of 2, and there's nothing over here. There's no number hanging on, so that means this does have direct variation, and if we graphed it, it would pass through the origin, and the constant of variation is -2. Okay, so what happens when we have points and we don't have an equation? So we have two options here. The first option, we know that y equals k times x. So I know that x is 1 and y is 5, so I can just plug them in and solve for k. And when I do that, I get k equals 5 divided by 1, and k equals 5. So I could write this equation as y equals 5x. The other thing you can do, and if you want to look at what k equals, we can write this in the formula k equals y over x, all I did was take this formula right here and just rearrange it. So I solved for k by dividing both sides by x. So this way we can just take our x value and our y value and plug it in. Y is 10, x is -8, and when we simplify we get the constant of variation, which is -5/4. Go ahead and try example 3 and 4. You can use either way. Use the y equals kx formula, or this and plug in x and plug in y. So k equals y over x. My y value in the ordered pair is 1. My x value is 6, and k equals -1/6. K equals y divided by x. My y value is -4. My x value is 3. So k equals -4/3. Okay, last two questions. Assume that y varies directly with x. So up in the notes up here at the very top, I said that the variables x and y vary directly, or they're proportional. So this is just a simple proportion. So if I use my k equals y over x, I have my y value here is 28, my x value here is 7, and my y value here is 52, and I don't know what x is. So if I solve that proportion, if I use my cross products, 28x equals 7 times 52, and we get 28x equals 364, divide by 28, and we get x equals 13. So if y is 28 when x is 17, then when y is 52, x has to be equal 13. And it's just a regular proportion that we did in elementary school. So we'll go ahead and do the same thing for number 2. If you want to pause the video and then check your answer, you can go ahead. So y over x, y is 2 2/3, x is 1/4. This time they're giving us x, so that's on the bottom of my proportion, that's 1/8, and we have to solve for y. And when we do that, we get y equals 12. So 2 2/3 over 1/4 is the same as 12 over 1 1/8. 28 over 7 is the same as 52 over 13. Okay, now it's your turn to answer the video questions. Multiple choice question 1. When y is 2.5 and x is 0.5, we need to find x when y is 20. And again, like those last two examples, you're just setting up a proportion. And keep in mind, your proportion is y over x. Number 2, tell whether the equation has direct variation. If it is, find the constant of variation. I'm going to cross it out and put has. So remember, you have to get your equation into y equals. Does it pass through the origin? That's your question. Be sure to enter your questions on the Google form for multiple choice question number 1 and free response question number 2.